Hmm. Have you ever wondered why comets have a tail? Have you ever wondered how laser tweezers are used in nanotechnology or how solar sails are used for navigation in space? Well, all these phenomena might seem very complicated and overbearing, but they have one simple mechanism behind them, and that is what we are going to discuss today. So, let's go and talk about radiation pressure.
The idea of light exerting pressure was first proposed in the 17th century by Johannes Kepler, who said that why does the comet's tail is away from the sun? He believed that it was pushed away by the sun by a force exerted by sunlight. However, due to lack of evidence, it was dismissed. But in 1873, Maxwell's electromagnetic laws predicted that light carries momentum, and this would have proven Kepler's theory right. And in 1900, a Russian physicist named Lebedev conducted some experiments which proved that Maxwell's theory of electromagnetism was correct, which also proved that light has momentum, and when force and he also measured force exerted by light on a reflector surface placed in a vacuum.
What do you feel when you go out in the sunlight? You feel hot, right? But do you ever get the feeling of being pushed by the light? Probably not. But in fact, you are getting pushed by the light, although by very negligible amounts. Now, what is this exciting phenomenon called? Yes, you're right. It's called radiation pressure. So how this works is when photons strike a reflective surface with some incident momentum, there's a force exerted on the surface which is perpendicular to it. By now you probably already understand that when photons strike a surface, some part of it gets reflected and some part of it gets absorbed. In the case of reflection, the reflected momentum happens to be twice the momentum at which the photons strike the surface. And in case of absorption, well, that's what leads to the change in momentum which causes the force acting perpendicular to the surface. This phenomenon is commonly observed in scenarios like solar sails and comet tails.
Let me explain to you the concept of light sails, also known as solar sails. I will explain the mechanism and also tell you how they are used to propel various satellites in space. Well, for starters, these solar sails have a very large area. The reason for this is that whenever there is some light reflecting off of this large sail, some of the photons impart certain momentum to this sail itself. Now, this imparted momentum will all band together to create some sort of force which will therefore propel it forward. Now, let me explain to you the various terms related to this diagram. Number one, we have an anomalous reflection. It refers to any reflection of light that does not follow the regular laws of reflection. Number two, we have specular reflections. These actually follow the laws of reflection, and over here, the angle of reflection is always equal to angle of incidence, as we know. Moreover, we have the yaw, roll and pitch, which are various movements that are done on the sail itself to basically navigate it throughout the vast expanse of space. Merits and demerits of using a solar sail to navigate and propel various satellites through space. Well, for starters, solar sails are cost effective and use a very low amount of fuel in order to propel these satellites throughout the vast expanse of space. However, there are some demerits as well. The demerits here are that, first of all, for this to work, the sail has to be very large in area, and this is very material intensive. Also, it produces a very small amount of propulsion, which isn't enough to propel these satellites over large distances. But you know what? Despite these challenges, solar sails, also known as light sails, are a very effective method and are one of the most futuristic ways of propelling satellites through the vast expanse of space.
To derive radiation pressure, we need to start with the Maxwell equations, particularly the Poynting vector. This is the equation for Poynting vector. And what is Poynting vector? Well, Poynting vector basically describes the directional energy flux, which is power per unit area. So here we have the formula for the Poynting vector. And now when we put this equation, we get this S is equal to E naught B naught divided by mu naught. Mu naught is the constant, which is this value. So from this we get the energy density of electromagnetic wave, which is E naught epsilon naught E square by 2 plus B naught square divided by 2 mu naught, which V naught is the magnetic field. So from here we get this equation, which is the energy density of electromagnetic waves. So we take the common out and we get this equation. But as we know, the speed of light is 1 upon E naught by mu naught, under root of E naught mu naught. So from here we get this equation and we solve it further and we get this. So now we have the force exerted by energy flux as F is equal to 2 mu by C. So we put the value of mu which we have derived from here, and now we just solve it. So in the end we get the radiation pressure formula as P is equal to E naught epsilon naught E square C square plus 1 by 8 C cube.
Well, by now, I hope you're as interested in learning more about radiation pressure as we are. To further fuel that excitement, let's discuss a few near future applications. The first one being acoustic levitators. What are they? They're devices which are capable of suspending objects in the air using radiation pressure, which can counteract gravity and ensure contact-free manipulation and experimentation. These instruments are becoming increasingly more common in labs which deal with zero contact experiments.
In the context of sterilizing medical products, radiation pressure is a widely used method. Well, how so? Basically, when it comes to sterilizing these medical products, the products themselves are exposed to high intensity gamma irradiation, which exposes any harmful organisms such as bacteria or fungi to this radiation itself, which can disrupt their molecular structure, thereby destroying them. And this is also a future research application of radiation pressure.
Another application of radiation pressure is laser cooling. Laser cooling is a technique that uses a laser beam to cool and trap atoms, molecules, and small mechanical systems to absolute zero. It has many applications, including atomic clocks, quantum computing, physics and chemistry, and gravitational fields. And with this, we come to a conclusion to radiation pressure. Thank you.